Now my dear students, we can go to the question number 16. When 1 mole of gas is heated at constant volume, temperature is raised from 298 to 308 Kelvin, heat supplied to the gas is 500 Joule, then which statement is correct? Here my dear students, we can apply the delta H is equal to delta E plus delta PV, that is the formula. First of all, we can see this formula, delta H is equal to delta E plus P delta V. Here you can see the delta V, 1 mole of gas is heated at constant volume, means volume is not changed. Here delta V is equal to 0. When delta V is equal to 0 means P delta V is equal to 0, and when then P delta V is equal to 0, it means W is equal to 0. And when this W is equal to 0, it means delta H is equal to delta E. Here you can get the delta H is equal to delta E. Now my dear students, second formula is our first law of thermodynamics. Delta E is equal to Q plus W. Now here we can see W is equal to 0 here. When W is equal to 0 at constant volume, so delta E is equal to QV. And here you can see the delta H is given, heat supplied to the gas is 500 Joule at a constant volume. When my dear students, constant volume means delta E is equal to 500 Joule, and here my dear students, it is a heat supplied to the system. So in system heat is increases, so plus heat is present, and delta H is already a 500 Joule, both are equal because. So delta E is equal to 500 Joule and delta H is equal to 500 Joule, you can see here. So my dear students, you can go to the question number 16, answer is B, because here delta E is equal to 500 Joule, you can see here, W is equal to 0, you can see here, and Q is equal to delta E, you can see here. So by the use of 1 and 2 formulas, we can get the conditions. This question is also asked in 2001 NEET exams, my dear students. Now we can go to the question number 17. Here question number 17, for the reaction, which one is true? First of all, you see the concept and formula, which formula is used in this question. This question is also asked in 2000 NEET. Our formula is delta H is equal to delta E plus delta nRT. This is our basic formula, and we use this formula always. Here my dear students, first of all we can calculate the delta Ng for this equation, because delta Ng is Np minus Nr. So my dear students, here we can see that what is the Np, gaseous moles of products. Here 2 moles of gas is present, here 3 is the liquid. So it is not, here 2 for Np and 3 for the here reactant, because here liquid is present. So you cannot count this liquid. So delta Ng is equal to, you can get the minus 1 for delta Ng. And my dear students, when you can get the minus 1 for delta Ng, then delta Ng is minus 1. So delta H is equal to delta E minus 1, so minus RT, plus minus 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 RT. So you can see this type of option where it is. Question number 17, answer, where is answer? Here minus RT 1, liquid, and 3 moles of here oxygen. So here you can get the minus RT. My dear students, you can go to the answer A. Delta H is equal to delta E minus RT. Because liquids are not taken, so it's cancel, this cancel, and 2 minus 3, that equal to minus 1. So your answer is A. This is your answer. This question is also asked in 2000 year. Now, my dear students, we can go to the question number 18. In an endothermic reaction, the value of delta H is a very theoretical and conceptual questions. What is the concept, my dear students? For endothermic reaction, a minus Q is there and delta H is equal to positive, because delta H is equal to HP minus HR. So, in endothermic reaction, enthalpy of the product is greater than enthalpy of the reactant. So, you can see here delta H is equal to positive. Now, second, for exothermic reaction, this is heat is liberated, and when heat is liberated plus Q heat is liberated, so my dear students, delta H is equal to negative. So, delta H, we can see that delta H is equal to HP minus HR. So, here when HR is greater than HP, enthalpy of the reactant is greater than enthalpy of the product, then you can get here delta H is equal to negative. My dear students, these two conditions are here, we can see here. So, in these two conditions here, endothermic reaction, so your answer is B, positive. We can apply these concepts and you get answers, that is positive. Now, my dear students, we can see here question number 19. Here question number 19, 1 mole of an ideal gas at 300 Kelvin is expanded isothermally. Isothermally means temperature is constant. From an initial value of 1 liter to 10 liter, the delta E for this process, he want the delta E for us. My dear students, here experimentally isothermally. So, what is the concept? You write your concept. Change in internal energy depends upon temperature. At constant temperature, the internal energy of the gas remain constant, because this internal energy depends upon temperature. So, your temperature is constant, because here you can see the isothermally means temperature is constant. When temperature is constant means internal change in internal energy is a constant. So, change is 0 for this question. So, this is the very easy question and calculation is not done in this question. So, my dear students, question number 19, you can go to the answer B, that is 0. Now, we can see here, my dear students, question number 20. During isothermal expansion of an ideal gas, is isothermal expansion means temperature is constant and expansion is done, and when expansion is done, it is a no work is done because it is a spontaneous process of an ideal gas. So, my dear students, it is a concept in isothermal. In isothermal, temperature is constant, expansion of an ideal gas occur spontaneously itself. So, no work done means W is equal to 0. So, when you can see that delta H is equal to delta E plus P delta V. Here this is the pressure P delta V, change in volume is 0, delta V is equal to 0, or you can see that delta H, delta E plus P delta V is the W, change in volume 0 means P delta V is 0. So, my dear students, here change in enthalpy is 0, no change in enthalpy is occur. So, here enthalpy remains constant because this 0 means delta H is equal to delta E. So, this is the concept, my dear students. During isothermal expansion of an ideal gas, its enthalpy remains unaffected. So, answer is your C, question number 20, answer is C. Now, we can go to the question number 21. For the reactions N2 plus H2 to give twice NH3 delta H. Here we can use the formula. What is the formula? Delta H is equal to delta E plus delta nRT. In this formula, you can see here what is the delta Ng. I give you delta Ng is equal to Np minus Nr. Here we can see the Nr, these are the ammonia as a gas, nitrogen is gas. It is not given in the reaction, but at room temperature these are present as a gaseous form. So, it is a 2 minus 4 that equal to minus 2. So, delta H E minus 2 RT, it is the delta H. So, you can see which option is correct, delta E minus 2 RT. You can go the question number 21 B option. Here delta H is equal to delta E minus 2 RT. This question is also asked in 1991 exam. Now, my dear students, we can see the question number 22. Here delta H is the change in enthalpy and delta E the change in internal energy accompanying a gaseous reaction. Then delta H is always greater than delta E. You can see the formula, and according to formula you can see the options. Delta H that is equal to delta E plus delta nRT. Now, all theoretical problems are given, all options are given, and you can see the options. If delta H is change in enthalpy and delta E the change in internal energy and accompanying a gaseous reaction, then delta H is less than delta E only if the number of moles of products is less than number of moles of the reactants. Delta Ng is equal to Np minus Nr. If you have Nr is greater than Np, means number of moles of products is less than number of moles of the reactants. Here you can see this option D, number of moles of products less than number of moles of the reactants, then you can get the negative sign. And my dear students, when you can get the negative sign, then you can get delta H is equal to delta E minus RT, 1, 2, 3, 4. It means when you can get the delta H, when in delta E, values of delta E, subtract the value of RT, then you can get the delta H. It means, my dear students, delta H is always less than delta E. So, this is the formula in concept, and we can obtain the correct answers, and correct answer is the D. Delta H is less than delta E. This question is also asked in 1990 exams, in NEET exams. So, my dear students, question number 22, you get answer D. Now, my dear students, we can go to the question number 23. Three thermochemical equations are given below, and based on the above equations, find out which of the relationship given below is correct. Here, my dear students, you can see here, number 1, carbon graphite O2 CO2, delta H reaction X kilojoule. Okay. Now, we can see here carbon graphite plus half O2 to give CO delta HR Y, and CO plus half O2 to give CO2 delta HR is equal to Z. Here, my dear students, we can find out the X. When, my dear students, both are add to this equation, you can find out CO is cancelled with this CO, and O2 over O2, you can get the O2 and CO2, because when you can X plus Y, then CO is cancelled. Carbon graphite, you can get this equation here, carbon graphite plus half O2, you get 1 O2 and CO2. So, my dear students, when Y plus Z are added, you can get X. So, my dear students, question number 23, you can go to the B option, and this is occurred by the Hess's law. It is occurred by the Hess's law. What is the Hess's law, my dear students? Liberated amount of heat is equal to the when this reaction is occurring in different path. It is a one step reaction in one, and these are the two steps reactions. When heat is evolved in two steps reactions are equal to the heat is evolved in one step reaction. So, my dear students, X, it is the heat evolved in one step, is equal to the when heat is evolved in two steps. So, this is verified by Hess's law, and this is given by Hess's law, this answer. Now, 23, you get the answer B, NEET 2013, this question is asked. Now, my dear students, we can go to the question number 24th. Standard enthalpy of evaporation delta H evaporation for water is 100 degrees Celsius 40.66 kilojoule per mole. The internal energy of the evaporation of water at 100 degrees Celsius in kilojoule per mole is. Here, what is the concept and formula? Here, my dear students, we can see here delta vaporization H degree, that equal to 40.66 kilojoule per mole. Okay. And what is the delta T? Delta T is the 100 degrees Celsius. So, it is converted to Kelvin 273 plus 100, and you can get the 373 Kelvin. Now, my dear students, we can see here the internal energy of evaporation you want. Means you can put the formula delta H is equal to delta E plus delta nRT. Here you want the delta E. So, you can see here delta E is equal to delta H minus delta nRT. Now, you can see here what is the delta H? It is 40.66 kilojoule, means it is converted to joule. So, 40.66 into 10 to the power joule, you can convert it, minus, my dear students, heat of vaporization means 1 mole of water is vaporized. So, you can delta N is the 1, change in moles 1 into R. R is taken in a joule. So, 8.314 multiply with the temperature in Kelvin, it is a 373 Kelvin. Now, my dear students, when you multiply these values and minus of these values, then you can get the delta E. My dear students, delta is the 37559, it is a joule per mole. And when you can calculate the kilojoule 1, 2, 3, you can get the 37.56, because here 59 is converted to 6 kilojoule per mole. Here, my dear students, you can get the plus sign. So, question number 24, your answer is A. My dear students, we can use this formula delta H barabar delta E, delta H is equal to delta E plus delta nRT. First of all, we can see the delta H here given in the numerical. It is also converted into the joule, 10 to the power 3. Temperature is given in degree Celsius. So, my dear students, it is converted to Kelvin, plus you can add the 273, it is converted to Kelvin. Now, we can see the formula delta H barabar delta E plus delta nRT. Here he want the internal energy, and delta is the internal energy of the molecules. So, you can put the values and get the answer. Answer is 37.56 kilojoule. Now, my dear students, this is the question number 24th. Is solve it, and this question is also asked in 2012. Now, we can go to the question number 25. Here we can see, consider the following process. Number 1, half A to give B, delta H is equal to plus 150 kilojoule. Number 2, 3B to give 2C plus D, minus 125 delta H kilojoule. Number 3, E plus A to give 2D plus 350, and he want the delta H for this equation. My dear students, what is the trick for this question and trick and concept to solve this question? My dear students, you can see here B is present in reactant. You can see these 3 equation. Here B is present in reactant, okay. But here 1B is you can see, and here 3B you can here see. Now, we can see here 3B, and in this B, 1B is here present. So, in product no B is present. So, it means this reaction we can take easily equation number 2, but equation number 1 we are not want, because this B is not we can get. So, my dear students, here if you multiply by 2 this equation, you can 2B, and both are added with each other. So, this is cancelled with each other, this, and you can get only B plus D, and you can get here in product E. But in this present in reactant. So, this equation is negative, means you reverse this equation, then you can get the 2D reverse of this equation or minus of this values, and here multiply by this 2. So, my dear students, this equation is converted 2D to give E plus A. When you can see that 2D E plus A, here reverse and half of this equation, reverse and half, because when divided by 2, divided by 2 and divided by 2, then my dear students, you can see this half a and this half a are cancelled with each other. Here 1 d is present, so this d is also here 2 d, and when this half, this d is also cancelled. So, my dear students, you can get for question number 25, you can get this delta H, equation number 1 minus equation number 2, and 1 is multiplied by 2 minus equation number 2 and minus equation number 3. When you can multiply this 2, it is multiplied by 2, and minus means reverse of this equation, it is converted to plus, then you can get the d plus 2c to give 3b. And minus of this equation, not divided, because when we can divide it, then you cannot get the b. So, you can only reverse. So, 2d to give a plus e. Here you can get the e in this product. Here you can get this reverse of this equation, negative 2c. Okay. So, you can not minus of this. So, you can get the 2c. Here you can easily get the 2c. This is the 2c, e and 2c. Because this is a reverse, so d is cancelled by this d, and you can get only d in this reactant. And my dear students, this b, 3b and 2b, so this 2b is cancelled by this b, so this b you can get the reactant. Now, here we can see what is the values. Here you can see the values. Number 1 equation, we can take as it is, but multiply by 2, this equation. Okay. This is a positive point, means you can get the plus 150 multiplied by 2. Then, my dear students, in equation 2, you can get as it is, no multiply by in equation 2, that is 125, and equation 3. Here this equation is reverse, and when this reverse equation, this minus 350 you can get, because here plus 355 is 350 is you can get in this equation. When this equation is reverse, then plus sign is converted to minus sign, and all these values are added. When you can add this all the values, then my dear students, you can get the delta H. Now, we can get the 350, 150 multiplied by 2, then you can get the 300, this is a 300, and 300 plus minus 125 plus minus here 350. This is the delta H. Now, we can calculate 300 minus 125 minus 350. So, my dear students, in question number 25, we can go to the answer B, because here 300 minus 475. So, you can get the minus 175 is the answer, kilojoule per mole. What is the trick, my dear students? You can see main equation, target equation, this is your target equation, and in target equation you convert these reactions according to the target. You achieve this target equation by the conversion of this or multiply of this 2 or 1, and when you multiply this equation you can multiply these values also, and you can get these values according to this equation and get the answer. This is a trick to get this type of process and calculate the delta H. Now, my dear students, we can go to the question number 26. In question number 26 is the same equations. In this equation you can see here target equation is this, and this target equation you can achieve by 1 and 2 equation. Here, my dear students, what is the trick and concept? My dear students, when you can multiply by of this second equation by 2, and then you can cancel with each other this twice FeO you can get here, twice FeO in product, means multiply of 2 and reverse this equation. Then you can get this equation twice FeO in product because it is present in reactant, and Fe twice Fe is reverse, minus, minus, minus and minus. So, my dear students, twice Fe is cancelled, here twice CO2 is cancelled, with this you can get only CO2, here CO, yes you can get the CO. So, my dear students, in question number 26 you can get the 1 minus 2 into 2, then you can get the minus 26.8 minus 2 into what is the 2, it is a minus 16.5, then delta H is equal to, my dear students, 26 plus 6.2 kilojoule. Answer is this one. Here minus minus plus, here you can multiply this, you can get the minus 26.8 plus 33. So, you can get the plus 6.2 kilojoule, this is the answer. And when 1 minus 2 into multiply by 2, you can get this target equation, you can achieve target equation. Now, we can go to the question number 27. Here, for which of the following equation delta H reaction equal to delta HF for the product? Delta H reaction is equal to the delta HF product for the product. What is the concept? Heat of reaction, heat of formation. When 1 mole of the substance is formed by its constituent, then liberated amount of heat is called heat of formation. you can see the liberated amount of heat by its constituent, and heat of reaction that equal to heat of reaction. Here you can see the N2O3. Question number 27, nitrogen and ozone. But in this question, elements of nitrogen and ozone. Ozone is enthalpy of the ozone is not 0. It must be enthalpy of the molecule must be 0. It is 0, but ozone is not 0. So, my dear students, because ozone is formed by oxygen plus O, and ozone is formed and it is a reversible reaction also. In presence of ultraviolet light, it is decomposed. So, my dear students, here you can see the answer is C, because enthalpy of the standard enthalpy of this xenon is equal to 0, standard enthalpy of fluorine is equal to 0, and XCF4, it is a 1 mole is formed by its constituent. So, my dear students, question number 27, you can go to the C option. Here enthalpy, standard enthalpy of the formation of this molecule is equal to 0. So, answer is C. Here enthalpy of this ozone is not equal to 0. So, this is second condition. So, delta HR and delta HF is equal to 0. When enthalpy of the formation is 0, then delta HR or delta H reaction is equal to delta HF. Delta H reaction is equal to delta HF when standard enthalpy of formation is equal to 0. So, my dear students, this is the answer. Question number 27, you get answer C. Now, we can go to the question number 28. Heat of combustion delta H for carbon solid, hydrogen gas and methane gas are. My dear students, you are target this reaction. You can calculate this, and what is the trick? Trick and concept for solve this type of question. You can see here delta H combustion for carbon solid that equal to minus 94 kilocalories per mole. You can see here delta CH for hydrogen gas that equal to minus 68 kilocalorie per mole. Now, we can see a third delta CH for methane CH4 gas that equal to minus 213 kilocalorie per mole. Now, target is over this. Here you can see carbon solid is present 1. So, you can get this directly this heat, because what is the combustion? When you can see the reaction carbon solid plus oxygen, you can get the CO2. So, in combustion you can get 1 mole of this carbon solid, here in this reaction you can get 1. So, you can here directly you can take in this heat. Now, we can see the question number reaction number 2. Here reaction in this reaction H2 plus half O2, 2 gives water molecule, and you can get the heat minus 94 kilocalories. So, my dear students, here you can get the 1 mole of H2 and here you can get the 2 mole of H2. So, you must be applied by 2. So, when this is multiplied by 2 in this heat, then you can get this heat, and this is also present reactant. So, my dear students, you added both the equation, multiply of this, and here you can see the combustion of methane. What is the reaction of combustion of methane? CH4 when heated, oxygen to give CO2 plus twice H2. Here you can see the combustion of methane, but here formation of methane. So, this heat is not required by you. So, this heat is minus, this heat is minus or negative to get this reaction, and you get the answer. Now, what we will do? Delta H that equal to minus 94, directly you can add, plus minus 68 multiplied by 2 you can taken, and minus 213. Now, we can see, you can get this reaction and get the heat. Minus 94 plus minus 136, because you can multiply by 68 multiply by 2. Then minus plus 213. My dear students, when you solve this, minus 94 minus 136, then you can get the minus 17 kilocalories, and this is your answer. Question number 28, your answer is A, minus 17 kilocalories. So, my dear students, you can see their answers minus 17 kilocalories, delta H. And this is a trick. You cannot put the all reactions, you can see only heat of combustions, and you can see the target reactions and get the answer. Now, my dear students, we can see the question number 29, which is asked in 2001. Change in enthalpy for the reaction, twice H2O2 to get twice H2 liquid plus O2. If heat of formation of H2O2 liquid, H2O liquid are this one, then what is the change in enthalpy? My dear students, we can use the formulas. Heat of formation that equal to sigma of heat of formation of products minus sigma of heat of formation of reactants. So, you can use, my dear students, here in this question you can use the water, heat of formation of H2O2 that equal to minus 188 and water that equal to minus 286. So, my dear students, you can use here 2 H2O2 and liquid water, here water you can use 286. These are the product and these are the reactants. So, you can see the water 2 multiplied by the minus 286 plus here product oxygen is also there, but oxygen is in normal condition at STP, heat of formation 0, standard heat of formation, then you cannot take this oxygen, only you can take these products water. Now, we can summation of heat of reactions. In this heat of reactants, only you can get the H2O2 minus 2 into 2 moles of H2O2, and this is 2 moles of H2O2, that is plus 2 multiplied by the minus 188. So, my dear students, you can get this heat, and this is the multiply and minus, you can calculate this minus 196 kilojoule per mole. You can multiply 286 minus 286 into 2 and multiply minus 188 into 2 minus plus, and you can minus this sign and you can get the minus 196. So, your answer is A. Question number 29, you get the answer A. Now, my dear students, we can go to the question number 30. What is the concept and formulas? Here, enthalpy of methane plus half O2 to give methanol is negative. If enthalpy of combustion of methane and methanol are X and Y respectively, then which relation is correct? Here, my dear students, we can see the reactions. Targeted reaction, methane plus half O2 gives methanol. This target is negative. Now, we give the reaction combustion when this methane heat of combustion O2 to form this CO2 plus twice H2, you can get the X heat of enthalpy, heat of combustion X. Now, we can see here number 2 reaction, heat of combustion methanol, CH3OH. This is the methanol is heated by oxygen to give CO2 plus water, and you can get the reaction, that is Y. Now, my dear students, we can see here this is the negative. So, this value is obtained when this X, here you can see the CH4 present in this reactant side, but this methanol is present in product side. So, X minus Y, so you can get the negative values. Here, my dear students, this is the H3, here this is the H1 and H2. Here you can see the X minus Y, and you can get the negative values. Why you can get the negative value? When you can minus X, this value must be minus X minus Y, then you can get the negative. So, my dear students, this minus plus, so you can see here this is the both are negative, minus X minus Y. So, this is a negative, minus X plus Y, that equal to negative, or you can say that minus X, Y minus X is equal to negative. It means, my dear students, X is greater than Y, because we obtain the negative values, and negative value is obtained when this X is greater than Y. When this X is greater than Y, then we can get the negative values. When this X is not greater than Y is greater than, you can get the positive values. And now, in this question, he wants the negative value of methanol. So, my dear students, X must be greater than Y. So, your answer is X must be greater than Y. Your answer is A. Question number 30, you can get the answer A.